Hello, and welcome to my Discrete Mathematics course at Istanbul Technical University. To start with, let me briefly introduce what we are going to study in this course. And as the name suggests, obviously, discrete mathematics is the study of discrete mathematical structures. And discrete, this term is emphasized here because we are going to study discrete mathematical structures as opposed to continuous ones, which can be described also as smooth objects. Now, discrete structures, what are they? For instance, integers, for instance, graphs, or logical statements, or certain sets that satisfy certain properties. They take on distinct and separate values, and essentially we can enumerate them. In other words, we can sort of list them. This is essential in understanding what is discrete and what is not. Okay, so discrete structures are usually associated with countable sets. Okay, so this is going to be one of the focus points of some upcoming lectures, but a very good way to define a discrete mathematical object is pointing out that it can be described as a countable set. Now, why are these important? Now, obviously, if you're a mathematician, it's important because it's mathematics. Apart from that, say you are an engineer, especially if you are studying either computer science or computer engineering or electrical engineering or informatics or a related field. Why are we interested in discrete structures? Because they are at the heart of computation, right? They give us a mathematical tool to represent computation because obviously we do computation via digital computers, and those operate in discrete steps and on discrete data because that data is represented as binary numbers, right? So this also emphasizes the importance of representation in discrete mathematics. So we will study, obviously, the definition of certain discrete structures and their relationships, which is important, also representations and operations on them, okay? So for instance, take sets, especially discrete sets. We will define operations on them. We will define representations. We will define relationships, and for instance, take graphs. We'll study graphs towards the end of this course. How can we represent graphs, right? Representation is also important in counting. We will study counting towards the middle of the semester. And when you encounter a combinatorics problem, for instance, representation is very important because if you find a good representation to a quantity, you can also come up with an easier method to obtain the number of ways to do that, etc. Okay, so all in all, obviously this will give us a way to understand discrete structures and to model computation. And this will also provide us with mathematical maturity in terms of approaching problems involving discrete structures and coming up with representations and obviously producing proofs. Now, one thing I have to point out at this point is that this is a graduate level course. And I know for a fact that in most universities and higher education institutions, discrete mathematics is taught at the undergraduate level. And at the graduate level, you usually encounter specific courses related to some of the subjects that we will study in this course. However, here we do have this graduate level discrete mathematics course to cater to students from a variety of backgrounds, maybe some of them non-engineers, maybe not studied discrete mathematics at undergraduate level, so on and so forth. Therefore, we do have a graduate level discrete mathematics course. And as it's a graduate level course, we expect a certain level of mathematical maturity already. In addition, you will expect to see some subjects that you may or may not encounter in an undergraduate level discrete mathematics course or text. Okay. In addition, we will follow an order of subjects that is specific to this course. And discrete mathematics is a subject that can accommodate very different orderings in its content. So in a sense, all subjects here are related to each other. However, they are not really foundational to each other. So you don't need to build one on top of another specifically. Therefore, if you look at some syllabi for different courses, or if you look at textbooks, you might see very different orders regarding the subjects. But obviously, some of the subjects require information from the others, or if you take it in a certain way, you see the relationships in a distinct way. And this order you see in this course is the one I came up with, and I believe works. And we will start with logic.